Now, Java programming, unit 2, classes and objects. First, introduction. First one is introduction. Class. Class is a template or blueprint for creating objects. Object is a basic runtime entity. All objects share same structure and behavior of a class. So objects are instances of classes. The method called by an object to satisfy the request is decided by the class of that object. All objects in a class use the same method. All objects in a class use the same method in response to same messages. Objects communicate each other to send and receive messages. It can communicate without knowing the details of each other's data. A class contains a number of objects, and each object can be given a different task. A class contains objects, and that objects contain method and data. These methods and data are called members of a class. Data or variables are called member variables, and methods are called member methods. If the variables or methods are referred by creating objects, then the variables or methods are called instance variables or methods. If the variables or methods are referred by the class by using the static keyword, then the variables or methods are called static variables or class variables, or static methods or class methods. Now, second one, class declaration and modifiers. Class declaration, a class is a template or blueprint for creating objects. An object is instance of a class. A class contains a number of objects, and each object can be given a different task. A class contains objects, and that object contains methods and data. These methods and data are called members of a class. Class syntax, syntax of a class, class name, type instance variable 1, type instance variable 2, type instance method name 1 parameter list, type instance method name 2 parameter list. Example, class A int L equal 10, B equal 20, int area return L into B. Modifiers. We divide modifiers into two types. One is called as a access modifiers, non-access modifiers. Access modifiers control the access level. Non-access modifiers do not control access level but provides other functionality. Access modifiers, it controls the access level. The different access modifiers are public, private, protected, and friendly, or default. If a class is visible to all classes, then public is used. If a class is visible to only that class, even it is not visible to its subclass, then private is used. If a class is visible to all the classes and its subclasses in same packet, but visible to subclasses in other packet, then protected is used. If a class is visible to all classes and its subclasses in the same packet, but not visible to other packages, then friendly or default is used. Non-access modifiers. For classes, we can use either final or abstract. Final, the class cannot be inherited by other classes. Abstract, the class cannot be used to create objects. For attributes and methods, you can use one of the following: final and static. Final attributes and methods cannot be overridden or modified. Static attributes and methods belong to the class rather than an object. Abstract can only be used in abstract class and can only be used on methods. The method does not have a body. For example, abstract void run. The body is provided by the subclass. Synchronized methods can only be accessed by one thread at a time. One thread at a time. Volatile. The value of an attribute is not catched thread locally and is always read from the main memory. Class members. Class is a template or blueprint for creating objects. Object is a basic runtime entity. All objects share same structure and behavior of a class. So objects are instances of classes. The method called an object to satisfy the request decided by class of that object. All objects in a class use the same method in response to same method in response to same messages. All objects in a class use the same method in response to same messages. Objects communicate each other to send and receive messages. It can communicate without knowing the details of each other's data. A class contains a number of objects, and each object can be given a different task. A class contains objects, and that object contains methods and data. These methods and data are called members of a class. Members of a class. Data or variables are called member variables, and methods are called member methods. If the variables or methods are referred by creating objects, then that variable or methods are called instance variables and methods. If the variables or methods are referred by the class using static keyword, then that variables and methods are called static variables or methods. Declaration of class objects. Objects are declared in two ways. For example, if A is a class, then it can be declared in two ways. The first way is A1 equal new box. The second way is A1 equal to new A. A1 equal to new box. This is the one way. A1 and A1 equal to new box. See here there is no A actually. Here you can write about the box. Box A1 equal to new box. Or the second way is A1 equal to new A. Or you can write A1 equal to new A. Instead of box, you write about the A. It is better. A1 equal to new A. The second way is A1 equal to new A directly. The new operator allocates memory for object at runtime and returns a reference to it. Here the object reference is A1 and allocates memory for A1. Example, class A int L equal to B equal to void display system out.println the length is plus L, system.out.println the breadth is plus B, class method demo, create the object A1 equal to new A1.display. In the above program, an object A1 is created at runtime, not A2. A1 is created at runtime. A method display is called by referring to these object references. Okay, assigning one object to another object. We are assigning one object reference variable to another object reference variable. We are not creating a copy of that object. We are only making a copy of that reference. For example, in the following program, the object reference D1, D2, D3 will point to the same object. Therefore, any change that we make to the object referenced by D3 will also affect the same object D2 and D1 is referring. Suppose if there are D1, D2, D3, if you are changed in D3, it is also affected by D2 and D1. We can create multiple references to the same object. See here in the XY. So what you have taken here, data D1 equal new data, D1 dot X equal 20, data D2 equal to D1. So D1 is referred by the D2. Now D2 dot Y equal to 40. Okay. Suppose again D2 dot X equal to 60, that 20 going to be changed. 20 going to be changed. Okay. That means we are created the object for D1. That D1 is referred to the D2. Okay. So through reference of this D2, if we change about the X value, it also going to be affected. Okay. So we are not taking about the D3, just taken about only the D2. Suppose if you want, you can write also D3 also. We are assigning the one object reference variable to another object variable. We are not creating a copy of that object. We are only making a copy of that reference. For example, the following variable, the object reference is D1, D2. See here, object references will not point the same object. D1, D2, D3, taken 3. Therefore, any change that makes to the object reference by D3 also affect the same object D2 and D1. But here I'm taking only about the 2, that is D1 and D2. Okay, D1 here dot X equal 20, then data D2 equal to D1. D1 is assigned to the D2 and D2 dot Y equal to 40. That means through data D2 reference, we are changing about the Y equal to 40. Suppose if I write D2 dot X equal to 40, then this D1 X dot X going to be changed about the 40. Okay, that is the referring. So you can also take one more, data D3 equal to D1, data D3 equal to D1, D3 dot X equal to, suppose if you take about the 60 like that, automatically the values D1 dot X, whatever it's going to referring, that value is going to be changed by D2 and D3. So here the object reference D1, D3 will find the same object. So because D1 taken D1 dot X equal 20, data D2 equal D1 means D1 is referred about the same object D2. Similarly, D3 equal to D1, again D3 is also referring about the same object D1. Okay, that means the object reference D1, D2, D3 will find the same object. Any change that make, suppose if we write D1 dot X equal to 20, D2 dot X equal to 30, D3 dot X equal to 40, that means if any change we make to the object reference by D3, suppose also affect the same object reference D1, D2. Suppose through D3 we change any X value, automatically through D2 and D1 also it's going to be changed. Okay, because D1, D2, D3, 3 are referring about the same object. So referring the same object means how we can write that one, data D1 equal new data, that is fixed. Then if we write data D2 equal D1, D1 is referring the same object, D2 is referring the same object D1. Similarly, if we write data D3 equal to D1, then D3 also referring about the same object. Through D3, if we change anything there, also changes about the D2, D1. That is what given about the top. Okay. Now, access control for class members. Access control for class members. And access never determine whether other access can use particular member variable or call a particular method. The Java programming language supports 4 access specifiers for member variables and methods: private, protected, public, and default. The following table shows the access permitted. Public, private, protected, default. Public means in a class, yes, package yes, subclass yes, world yes. Private means yes, remaining all are no's. Protected means class yes, package yes, subclass yes, but world is no. Default means yes, yes, but subclass no and world no. The first column indicates whether the class has an access member defined by the access level. A class access always has access to its own members. The second column indicates whether the class in the same package as a class have access to the member. The third column indicates whether subclasses of the class, regardless of which package they are in, have access to the member. The fourth column indicates whether all classes have access to the member. Okay. Now, accessing private members of a class. In a class, if variables are private and methods are public, that methods are accessible in main function. If both variables and methods are private, then that members of a class is not accessible in the main function. So remember, variables are private, methods are public, then only that can be accessible in main function. If both variables and methods are private, they cannot be accessible. The example program: private int x equal to 100, public. So private variable, public function. Then in a function, you can call as a data d1 equal to new data. Not data here, it is data here. This is the data. This is the data. Data d1 equal to new data d1 dot display. So it's going to be called about the display function. Okay. Then constructor methods for a class. Constructor or constructor method. When an object is created, it immediately initializes a constructor, and the constructor can be called automatically. Special properties. The constructor name and class name both are same. Constructors have no return type and no void. If a constructor is not defined explicitly and object is created, then it automatically calls the default constructor. The default constructor initializes all instance variables and class variables 0. Once we define our own constructor, the default constructor cannot be used. Syntax of a constructor: class name parameter list code. Example 1. A constructor with no parameters. See here, int L comma B constructor, we define L equal to B equal to area. Then in constructor demo, what you are doing? You are just calling that A1 equal to new A, that is creating object into R equal to A1 dot area. Through A1, we are calling the area, and the area is going to be displayed. Second one. A constructor with parameters. Parameters means here you can write L comma B into U comma into B. So here L equal to U, B equal to U. Suppose here int L comma B, A int L comma int B, then both are same. In that case, use this keyword: this dot L equal to L, this dot B equal to B. Okay, in the area written L into B, same thing. But here you pass about the A1 equal to new A. Here you are passing about the parameters. Remaining things are same. Now, overloaded constructor method or constructor overloading. In a class, if 2 or more constructors having number of parameters are different or types of parameters are different, then it is called constructor overloading. See here in this constructor, A is a default constructor without parameters. A is a constructor with parameters. Area is the same function. Now what we are doing here, I am creating into A1 equal to new A, A2 equal to new A. So here without parameters, here with parameters. And constructors are going to be called. Through these constructors, you can call about A1 dot area. Similarly, you can call A2 dot area. Now, nested classes are inner classes. A class inside another class is called nested class. A nested class can access the members and private members of the outer class. The nested class can be two types: static or non-static. A static nested class can access only static members, and without creating an object in outer class, we cannot call the inner class member. So the static nested classes are rarely used. Non-static nested class is called inner class. Now class A int L equal to 100. So taken one variable is in class A. Class inner, I'm taking one more variable. Now in display function, the length is L. But for inner class, create the object for inner. Through object reference, you call the B value. This B value. Okay, now here normally A1 equal new A1 dot display can write. Next, final class and methods. The final keyword is used to attributes, methods, and classes. If you use final keyword to a attribute or variable, then that variable cannot be changed. It consists of using final to prevent overriding. So overriding means in superclass and subclass, if function name is same, method name is same, then it is called overriding. So if you use final keyword to a method, then that method cannot be overridden. That means if you write void display here, if you write final here, then this method again in subclass you cannot write. If you write that one, then it gives error. So writing a method in a class, same method in a subclass, then it is called method overriding. Now method overriding is not possible. It gives about the error. So because in the above program we use final before void display method in class A, then that method cannot be overridden. Using final to prevent inheritance. That means before class we use final, then this class cannot be cannot be inherited. So this class you cannot write about the class inheritance. Okay, inherited class. If you use final keyword to a class, then that class cannot be inherited. So if the class is declared as final, then the class can prevent from inheritance. Using final to a variable, already you know this one. If you write final L equal to 10, and if you change L equal to, it gives error because 10 is nothing but the final. Passing arguments by value and by reference. Passing arguments by value or call by value is also called. If the values are passed to a method, then the changes to that values in that method cannot be affected to the passed value. This is called call by value. Simple data type is called call by value. That means you take about the function void display int L comma B, L equal to L plus B equal to B plus 20. Now write the object A1 equal to A. So give the parameters L equal to B equal to 20. Before passing arguments, print LB. Now pass the values L comma B, and again after passing arguments, right, before passing LB values, after passing LB values, both are same. But in case of second case, that is that is nothing but passing arguments by reference or call by reference. If an object is passed to a method, then the changes to that values in that method can affect the passed object. This is called call by reference. Objects are passed by call by reference. So take about the parameter values L10, B20, void display A2. So here I'm taking the object reference. Through object reference, I am increasing about these values. Okay. Now create the object A1 equal to A. Before passing arguments, print L value, B value. Now pass the object A1 dot display A1. So you are passing about the object A1. If now print A1 dot L and A1 dot B. Before passing arguments, after passing arguments, both are not same, both are different. From this, you can say that value going to be changes in call by reference. Keyword this. The keyword this is used to refer the current object or current data. If the local variable name and instance variable name both are same, then the local variable hides the instance variable. So to refer the instance variable, this keyword is used. Local variable, say for example, int L comma B, A int L comma int B. Here, local variable is int L comma int B. Then the current variable is L comma B. Then this current variable hides the local variable. So to refer current data, local variable, then both are same. Then the local variable hides, local variable hide the current variable. Local variable hide the current variable. To refer the current variable, then you can use this dot L equal to L means this int L, the value is equal to this local variable L. Int area remaining is same program. When you pass A to 10 comma 20, then find out about the area. Okay, that is int R equal to A1 dot area system dot out dot println, and the area is also. Now next one, methods. Now come to the methods. Introduction. Class is a template or blueprint for creating objects. Object is a basic runtime entity. All objects share same structure and behavior of a class. So objects are instances of classes. The method called by an object to satisfy the request is decided by the class of that object. All objects in a class use the same method in response to same messages. Objects communicate each other to send and receive messages. It can communicate without knowing the details of each other's data. A class contains a number of objects, and each object can give a different task. A class contains objects, and that object contains methods and data. These methods and data are called members of a class. Data or variables are called member variables, and methods are called member methods. If the variables or methods are referred by creating objects, then the variables or methods are called instance variables or methods. If the variables or methods are referred by the class, then the variables or methods are called static variables or methods. Defining methods. A method representing name, return type, or void in parameter list. Syntax of a method is type, method name, parameter list, body of the method. Now in this important one is no return type and without parameter list. So without parameter list, that is void display. No return type, that means void. Here you define L value, B value, void display. L value, B value, print it. Now just A1, new A1 dot display, right? No return type and with parameter list means when void display, right, int L comma int B, print this values LB and pass these values in the function. Now second one is third one, return type and without parameter list. Return type is there int, no parameter list here. That means int L equal to and B equal to the return L into B. So this value is going to be stored in R. So then print about the R. Here return type with parameter list. Return type is there int, parameters are there L comma B. These parameters are passed here, and after passing these values, it's going to return the values again store in R. So print that R value. Now next one is overloaded methods. Overloaded methods. In a class, if two or more methods having same name, but number of parameters or types of parameters are different, then it is called method overloading. Say here in this case, int L equal 10, comma B equal 20, in the area, return L into B1, in the area, int L. So this is one without parameters, with parameters. Now you pass about the without parameters int R1 equal to A1 dot area, and you pass about parameters in the R2 equal to A1 dot area, then print about the area. Class objects as parameters in methods. Class objects as parameters in methods. That is, class object you can put as parameter in a method. A method can take as objects as a parameter. A method can take as object as parameter. If you pass an object as an argument to a method, the mechanism that applies is called pass by reference. In pass by reference also like that, call by reference also like that too. Because a copy of the reference contained in the variable is transferred to the method, not a copy of that object itself. Now example program is given by in the A equal to 100. Now void display A1. That means I'm passing about the object as a parameter A1. Through A1 I'm printing about the value. That's all. But here you pass about A1, that is object reference. Same call by reference also you can write for this example. Access control. Refer access control for class members. Okay, already it is there. Now recursive methods. In a class, if two or more methods having the same name but number of parameters or type of parameters different, then it is called method overloading. In recursive methods, recursive method. See here it is nothing but not method overloading. Recursion. So this definition is wrong actually. Recursion means a method called by itself is called as a recursive method. But actually it is the method overloading. But here it is asked about the recursive methods. Recursive method is a method that called by itself is called as a recursive method. A method that called by itself is called as a recursive method. The example program is given by class A, int fact int n. If n is not equal to 0, return n into fact n minus 1, else return n. So here it's going to be called the method by itself. Is called as a recursive method. So we are finding about the factorial of 4 by using this recursive method. Nesting of methods. A method can be called by using only its name by another method of the same class. A method can be called by using only its name by another method of the same class, that is called nesting of methods. See here, method is, what is the method? Void display method. Now, void display method, okay. So data d1.show. So this show method. So this show method is calling in another method, void display. Then it is called as a nesting method. These two are nesting method because in method inside another method is there calling. That is called as a nesting method, nesting of method. Okay. So class object demo, data d1 equal new data d1.display. Overriding methods. If a method in superclass and subclass having same signature, that means method name, type of parameters, return type is same. Then the subclass method override the superclass method. That is called method overriding. That means void display in a class A. So same you are writing in a subclass void display. But this display method we are calling in super.display in here. That means because this void display both are same, then it can hide. So to call this, you write super.display. Now call display method, then both can be called attributes final and static. That is attributes final. You can refer unit 1 already there. In class 2 our method and same name, but different, then it is called method overloading. Again, here it is there wrong. So this is not there actually. So just attributes final you have to write refer unit 1. Then static keyword. So you can see about the static keyword. Already it is completed previously, but anyhow repeating here. Without creating objects to call data and method, we use static keyword. If you declare both variables and methods as static, then only we can call that data and methods without creating objects. The static itself uses a static method. The static methods can access only static data. The static variables and methods are also known as class variables and class methods. These class variables and methods refer through class only. We cannot refer these are super keywords to static data or static methods. The most common example of static method is main method. The syntax of class which represents static data and methods is given by class name, static type variable 1, static type variable 2, static type method name 1, static method 2. Program is nothing but the static here in L equal to and B equal to static void display system.out.println L system.out.println B. Just don't create the object, just capital A dot display, right? Automatically through class reference you can call about this function. Thank you. This completed about the second unit.